Hello friends, welcome to Mass Academy. In today's class, let us talk about the equilibrant force. The equilibrant. Equilibrant we will represent by the letter E. And to show this is a vector, we will draw an arrow above that. So what is equilibrant force? Equilibrant force is equal to, I will write it is equal to negative R. What is this R? R is the resultant force. So what is equilibrant force? Equilibrant force has same magnitude as the resultant force, but the direction will be opposite to the resultant force. So what is equilibrant force? Equilibrant force has same magnitude as the resultant force, but its direction will be opposite. For example, here on this object two forces are acting. One force is acting, this is a 120 Newton force that is acting to the right side, and another force, a 40 Newton force, that also acting to the right side. So two forces are acting to the right side on this object. Then what is the resultant force here? Resultant, that is equal to, the resultant of these two forces is equal to 120 plus 40, that is equal to 160 Newton. So the resultant is equal to 160 Newton to right. The direction is towards right side. Then what is the equilibrant here? Equilibrant, that is equal to, what is equilibrant? It is negative of resultant force, means that is equal to resultant force, but it will be in the opposite direction. So equilibrant, that is equal to 160 Newton to the resultant is to the right side, so equilibrant will be to the left side, to left. Which means if you apply that force here on this object, that is this 160 Newton to this side, to the left side, then the other two forces will be balanced. All other forces will be balanced. So equilibrant force is a force that will balance all other forces acting on an object. The force which balances all other force acting on an object is called equilibrant force. The force that balances all other forces acting on an object, that is called equilibrant force. We will discuss equilibrant force with another example. So here we have an object and two forces are acting on this object. One force that is acting to the left side, a 150 Newton, this is acting to west, I will write, and another force, a 50 Newton force, that is acting to east. So how to calculate the resultant force and equilibrant here? Resultant, that is equal to 150 minus 50. Why? Because they are acting in the opposite direction. That's why we are subtracting. That is equal to 100 Newton to west. So this is the resultant force. Then what is equilibrant? Equilibrant, that is equal to, it will be same as resultant force. Okay, it will be equal to resultant force, but the direction will be opposite. If resultant is to the west side, then equilibrant will be to the opposite side, that is east to east. Then we will take another example. If vectors are perpendicular, if two vectors are acting on an object, two forces are acting on an object at an angle 90 degrees. So how to calculate the resultant and equilibrant? For example, here on this object two forces are acting. One force is acting to this side and another force is acting to this side. For example, this is a 3 Newton force and a 4 Newton force. So these two forces are acting on this object. So how to calculate the equilibrant vector or equilibrant force? So what is the resultant here? Resultant is from the starting to the end, right? So this is how we draw the resultant. And here these two vectors, these two forces are acting at an angle of 90 degree. So we will calculate the resultant using the equation square root of 3 square plus 4 square, means we are using Pythagorean theorem. So when you calculate this, you will get 9 plus 16, so it will be square root 25, that is equal to 5 Newton, right? So 5 Newton is the value of the resultant. Then how to calculate this angle of resultant, this theta angle? So to calculate the angle, we will use this equation of tan theta. Tan theta, that is equal to opposite side over adjacent side. So what is the opposite side of this angle? Opposite side to this angle is 4 Newton, right? This is the opposite side and this is the adjacent side. So 4 divided by 3, theta equal to tan inverse 4 by 3, 4 over 3. So what is tan inverse 4 over 3? That is equal to 53.1. So this angle theta, that is equal to 53 degree. So this is the resultant vector. So how to calculate the equilibrant vector? Equilibrant vector, that is equal to resultant, but the direction will be opposite to the resultant. So equilibrant vector, the magnitude of the equilibrant vector will be 5 Newton. So what is the direction? Direction will be opposite to the resultant, right? This is resultant. So equilibrant vector will be along this direction, in the opposite to the resultant vector. And what is the angle to the equilibrant from the positive x-axis? This is the positive x-axis. So you need to calculate this angle. So how to find this angle? To find that angle from, we know that this angle is theta, right? So this angle will be theta. Theta you calculated 53. So this angle will be 53 degree. And the angle from here to here, up to here, this is 180 degree, right? The angle from here to here, 180 degree plus 53 degree. So the equilibrant, that is equal to 5 Newton, the magnitude, and the angle theta, that is equal to 180 plus 53. 180 plus 53 from the positive x-axis. Okay, whenever you calculate the angle, you calculate from the positive x-axis. So 180 plus 53, that is equal to 233 degree from the positive x-axis. That is the direction of the equilibrant force. Now we will discuss another example. That is, two forces are acting on an object. They are not perpendicular, means they are acting at an angle that is not equal to 90 degree. So here we will draw a x-axis and this is the y-axis. So this is the positive x-axis and two forces are acting on this object. The object is here. One force is acting, that is 44 Newton force, that is acting at an angle 60 degree from the positive x-axis, and another force that is acting along the y-axis, means at an angle 90 degree from the positive x-axis. So this force is, magnitude of this force is 33 Newton force, that is acting along the y-axis. So how to calculate the resultant vector and how to calculate the equilibrant of these two forces? So first we will draw the vector diagram. To draw the vector diagram, I will draw the vector diagram here. So this is our x-axis. This is the x-axis and this is the y-axis. So here this is one of the force, that is 44 Newton, and this angle is 60 degree, and another force that is acting, the second force is 3 Newton. So when we draw that force, we need to start from the tip of the, whenever you draw the vector diagram, it is tip to tail method you need to draw. So when you draw the second vector, the tail of the second vector, you need to start from the head of the first, okay, the tail on head. So this is the head, and the resultant is from the starting to the end. So this is the resultant force. Resultant force we will represent by the letter R. So how to calculate the, so this is a vector diagram, right, and this force is 33 Newton. So here these two vectors are acting at an angle that is not equal to 90 degree. So we will use law of cosine. We will use the cosine law to calculate the resultant. R is equal to square root of 44 squared plus 33 squared minus 2 multiplied 44 multiplied 33 multiplied cos theta. So here what is this angle? That angle is theta, and what is the value of that angle? So here we know that if I draw like this, if this angle is 60 degree, then this will be 60 degree and this will be 90 degree, right? So 60 plus 90, that is 150 degree. So this angle will be equal to 150 degree. 150 degree. Why? 60 plus 90. 60 plus 90 is 150 degree. So we will calculate the resultant using law of cosine like this. Square root of 44 squared plus 33 squared minus 2 multiplied 44 multiplied 33 multiplied cos 150, that is equal to, we will calculate this, 44 squared plus 33 squared minus 2 multiplied 44 multiplied 33 multiplied cos 150 square root of the answer, that is equal to 74 Newton. Okay, 74.4 Newton. So the resultant is 74.4 Newton is the value of the magnitude of the resultant force. Okay, 74.4 Newton. So what will be this angle? To calculate that angle, we will use sine law. Sine law. What is sine law? So we need to calculate this angle theta, right? This angle we need to calculate. So sine theta divided by the opposite side. Sine theta divided by opposite side, that is 33 Newton. 33, that is equal to, we know the value of this side, right? This side is 74.4. R is equal to 74.4. So 74, we need to write the angle theta first. So here this is 150 degree, right? So 150 sine of 150 divided by this side 74.4. What is sine law? Sine law states that the ratio of side divided by sine of the opposite angle, that will be equal, means 74 divided by sine 150, that is equal to 33 divided by sine of this angle. So we are just rewriting that equation like this. So we can calculate the angle theta. So here sine theta, that is equal to sine 150 divided by 74.4 multiplied, this 33 will go here, 33, that is equal to how much? Sine 150 divided by 74.4 multiplied 33. So I am getting 0.22. We need to calculate theta. Theta, that is equal to sine inverse 0.22, that is equal to sine inverse 0.22, 12.7 degree, 12.7. So this angle is 12.7 degree. So what is this total angle? 60 plus the angle from the positive x-axis. Okay, angle from the positive x-axis. This is the positive x-axis. So angle of the resultant, this is our resultant vector, right? Angle of the resultant from the positive x-axis, that is 60 plus, why 60? 60 is the angle from here to up to this vector, right, up to this force, and from here to here, that is 12.7. So 60 plus 12.7, that is equal to 72.7 degree. So what will be the equilibrant vector here? Equilibrant vector will be, so if we calculate the equilibrant vector, the magnitude will be same as the resultant. Magnitude of equilibrant vector, that is 74.4 Newton. 74.4 Newton, because magnitude of equilibrant will be always same as the magnitude of the resultant, but the direction, the angle from the positive x-axis will be different. How much? So this is the resultant vector, right? Resultant vector R. So equilibrant vector will be same length but in the opposite direction. So it will be like this, opposite to the resultant vector, that is the equilibrant vector. And what is the angle to the equilibrant from the positive x-axis? So here you can see from here to here, from here to here it is 72.7 degree, 72.7. From here to here, that will be 180 degree. So how to find the find the direction, means find the angle to the equilibrant vector, equilibrant force from the positive x-axis? From this, means with this angle add 180 degree. So 72.7 plus 180, that is equal to how much? 252.7, right? 252.7 degree from the positive x-axis. This is how we calculate the angle to the equilibrant vector from the positive x-axis. First you calculate the angle from the positive x-axis to the resultant vector. With that angle add 180 degree. For the angle theta to the resultant vector plus 180 degree will give you the angle to the equilibrant vector from the positive x-axis. Thank you friends for watching this video, and I request you to please subscribe my channel. Thank you.